Hello everyone, welcome to my video. Today I am going to discuss the topic called derangements. Nothing is in its right place. Let's get into the video. Introduction to derangements. Derangement or a mathematical concept that refers to permutations in which none of the elements appear in their original position. This means that in derangement, nothing is in its right place. Derangements are important in combinatorics and have applications in various fields including cryptography and computer science. Formula for derangements. The number of derangements of a set with n elements is given by the formula factorial n equals n factorial of 1 minus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial plus so on plus minus 1 power n by n factorial. This formula can also be expressed as factorial n equals round n factorial by n, where e is the base of the natural logarithm. The number of derangements grow rapidly as n increases, making derangements an interesting mathematical topic to explore. Properties of derangements. In a set of elements, the probability that a random permutation is a derangement approaches 1 by e as an n approaches infinity. The number of derangements of a set with n elements is always an integer. Derangements satisfy the property factorial n equals n minus 1 factorial n minus 1 plus factorial n minus 2. Applications of derangements in cryptography. Derangements are used in cryptography to create secure encryption algorithms by shuffling the positions of elements in a permutation. Derangements help in creating a complex and secure encryption scheme. The properties of derangements make them valuable in ensuring the confidentiality and integrity of sensitive data. Derangements in computer science. In computer science, derangements are used in algorithms for generating random permutations. Derangements help in ensuring that the elements in a permutation are shuffled in a way that none of them appear in their original positions. Efficient algorithms for generating derangements are essential in various applications such as random number generation and data encryption. The principle of inclusive exclusive for derangements. The principle of inclusion exclusion can be applied to derangements to calculate the number of permutations that do not fix any element. This principle helps in systematically counting the number of derangements and avoid double counting. By using the principle of inclusion exclusion, mathematicians can derive formulas for derangements and solve complex combinatorial problems. Recursive approach to derangements. Derangements can be calculated recursively using the formula factorial n equals n minus 1 of factorial n minus 1 plus factorial n minus 2. This recursive approach breaks down the problem of finding derangements into smaller subproblems, making it easier to compute the number of derangements for larger sets. Recursive algorithms for derangements are efficient, can be implemented in computer programs for various applications. Derangements in computational groups. Derangements play a significant role in permutation groups, particularly in the study of symmetric groups. The set of all derangements in a permutation group forms a subgroup known as the alternating group. Understanding the properties of derangements in permutation groups helps in analyzing the structure and behavior of group elements in abstract algebra. Derangements and pigeonhole principle. The pigeonhole principle states that if n pigeons are placed into n minus 1 pigeonholes, at least one pigeonhole must contain more than one pigeon. Derangements can be viewed as an application of pigeonhole principle, where the elements in a pigeonhole are pigeons and their original positions are pigeonholes. The concept of derangements provide a mathematical way to analyze arrangements that violate the pigeonhole principle. Derangements in probability theorem. The probability theory in derangements are used to calculate the probability of certain outcomes in random experiments. The concept of derangements help in determining the likelihood of events where elements are not in original position. By studying derangements in probability theory, mathematicians can make informed decisions and predictions based on the principles of combinatorics. Derangements and error detection. In error detection and correction codes, derangements are utilized to create redundancy in data transformation. By shuffling the order of data bits using derangements, error in transmission can be detected and corrected. Derangements provide a reliable method for ensuring data integrity and minimizing the impact of errors in communication systems. Derangements are and network security. Derangements are used in network security protocols to enhance data encryption and authentication mechanisms. By incorporating derangements into cryptographic algorithms. Networks administrators can strengthen the security of data transmission. Derangements play a crucial role in safeguarding sensitive information and preventing unauthorized access in digital communication networks. Derangement in game theory. In game theory, derangements are employed to analyze strategic interactions and decision-making process in competitive scenarios. Derangements helps in modeling random permutations of player strategies and outcomes in games. By applying derangements in game theory, researchers can study the dynamics of strategic interactions and develop optimal strategies for players. Derangements and future directions. Derangements are fascinating mathematical concepts that has a diverse application in cryptography, computer science, probability theory, and other fields. Further research and derangements could lead to the development of advanced encryption algorithms and combinational optimization techniques. By exploring the properties and applications of derangement, researchers can uncover new insights and innovatives in mathematics and related disciplines. Thank you for watching this video.